So let's start. It's already 8:05. So we had an introduction session on Saturday. So where I have discussed about what is going to be the course contents from concept point of view and also from tool software training point of view. What would be covered that we discussed in demonstration session. And then we also discussed a definition for what is data modeling. I hope you remember, Mahbub, this definition. Data modeling is about analyzing the data requirements and then defining them for a useful purpose. So once we have defined them, it can be used. Then we discussed information engineering notation. So information engineering notation is used to develop entity relationship diagrams. And we discussed what is entity, what are relationships, what are attributes, what's the purpose of attributes. Then we used this simple example to learn different symbols used in information engineering. And then we discussed about these symbols. This relationship is each employee working in 0 or 1 department, and then each department can have 0, 1 or more employees working. So we discussed these symbols and its meaning and how to read them. And that is a good starting point. Let me close this. And that's a good starting point for us to do conceptual modeling. And today what we are going to do is we are going to practice conceptual modeling. We will do an end-to-end exercise where we will look at a set of software requirements. Let me open that. So what we have here is a set of software requirements, and which is expressed in text format. So if we get such a set of software requirements, how we can translate this into a relational database design? What is that whole process we have to go through? That is what we are going to do today.
Okay.
Yeah. So what we are going to, the approach what we are going to do is, when we do conceptual modeling, it is also sometimes often it is called business data modeling also. If we have a set of business requirements, then analyzing it and then finding out significant entities, and then also finding out the important relationships between those entities, and then documenting them, we can call it a conceptual modeling. And conceptual modeling is informal. That means there are no formal definitions for what is conceptual modeling. So if someone come up and tell you that, okay, this is conceptual modeling, and you can always put forward your opinion on that because it is an informal term, and then there are no precise definitions for what is conceptual modeling and what is a conceptual model. So we will be doing conceptual modeling now by reading this set of business requirements, and then we will use Erwin for documenting that conceptual model, and also then translating that conceptual model to a logical physical data model. And finally, we will even build corresponding database. That's what we are going to do. Okay. Now let's start doing the conceptual modeling exercise. What we have to do is we have to go through these requirements one by one. And this is a set of software requirements for a banking information system. Bank is something we are all familiar with. Normally we will go to a bank, we will open an account, then we will deposit cash into that account. Then whenever we need that cash, we will take it back. And that is the primary business process that we are aware of in a bank. And then there will be a lot of different type of account. It can be a savings bank account, current account, then credit card account, loan accounts. There are different type of accounts banks may support. So we will just consider something which is very simple and which we can really work with now. Okay, so what we will do, we will go these lines one by one, and we will try to find out, are there any significant entities mentioned anywhere? Well, let's look at this. Here it says bank offers savings or current accounts. So is there any significant entities mentioned here? Yesterday we discussed what is an entity. An entity is, from a data modeling perspective, an entity is anything about which we want to collect data. So when someone say that, okay, this bank offers savings or current accounts, can you see anything here about which we want to collect data? So Mahbub, if you want to add, if you can just want to tell me something, you can say, can you find any entities about which we may have to collect data? Just imagine we are in the process of developing software to support a banking process. Yeah.
Yeah, we need to have account type.
Yeah. So here accounts is something about which we want to collect data, and then account type is going to be some information about accounts. So that's correct. So I'll just make it bold. Account is something about which we want to collect data. Here it says savings or current, means it is talking about account types. So account has to be a significant entity. Then do you see anything else here?
No.
Okay, we'll go to the second row. Bank has multiple branches. Do you see anything here about which we may have to collect data in the system?
Yeah, branches.
Yeah. Yeah. Accounts. Bank has multiple branches. Then each branch has branch manager. Do you find any significant entity in this line? Anything about which we have to collect data?
Employee.
Yeah, okay. So employee, anyway, it is mentioned here. So I'll just mark it as bold. So in this here, branch manager is something about we have to model it. It can be in different ways. Let's mark it that branch manager is something, a data element that we need to cover. Then here we have each employee of the bank has a supervisor. Here you have identified employee, maybe an entity, and then anything else on this line?
No.
Okay. Now here we'll go. A customer can open multiple accounts. Can you see any significant entity about which we may have to collect data? Accounts is something we have already identified. We have to collect information about accounts because normally there will be an account number.
Customer.
And we do all the, yeah, customer. Now we go to next line. Customer can deposit or withdraw cash from account. Do you find anything? Account is something we have already covered. Customer we will have the information about.
Transaction.
Then yeah, transaction. So we have something which is talking about a transaction here. Okay, then customer is not allowed to withdraw more than 50,000 in a single transaction. Customer we have already considered as an entity. Then withdraw is actually an activity which is performed by customer, which we already considered transaction, which is can be deposit or withdraw. Then it says that withdraw should not be more than 50,000 in a single transaction. Okay, so since customer and withdraw are already identified, then this is a kind of a value level semantics, something which we consider as a business rule that has to be accommodated in the model, but not necessarily an entity. So let's leave it here. So we will revisit these during the model validation process. We'll go to the next line. An account is always opened in a specific branch. Account we have already considered. Then account is always opened in a specific branch. Branch we have already considered. So this particular line is talking about some sort of association between account and branch. So we will revisit later, and since account and branch is already considered as entities. Okay, then finally we have customer can subscribe transaction notifications in email, phone, or address. Do you find any specific entities here?
Address.
Yeah. Probably address which include email, phone, and everything. So the contact information as well, right? All sort of contacts, email, phone, and address. So another thing on this line is it says customer can subscribe transaction notification. So it is also talking about something which is notifications. It can be not necessarily much of data collection about notification. It is up to that particular system situation to decide whether you want to collect some information about notifications or not, because there is sending a notification is an activity here. And what do you want to collect some information about that? Probably customer preferences to send notifications or not. And then if a customer have already preferred to send notification via email, send that. If customer preferred notification via phone, send that. So probably notifications, but not necessary. It is something we have to consider. Okay. So any other comments, Mahbub? We have this. We have reviewed this, and then in case of a bank, there may be some information which may be one instance of information we may collect about a bank as well. So if there is some information about at a bank level, we may want to keep it in the system. So we can even consider bank as an entity. Not necessarily it will have many instances in a normal banking system. So that we can effectively associate bank with branches, etc. If we want to collect some information which is at a bank level, we will have an entity called bank as well. Okay. Any comments, Mahbub?
No, I'm good. Thank you.
Okay. Okay. Now we have gone through these. This is not necessarily what we do in the first iteration is not necessarily a complete, thorough process. First, when we first go through the requirements, and then certain things may be very evident that we need to have information about these, and then we have to just mark them, and then when we are ready to go and do conceptual modeling, we can take a software which can help us to do conceptual modeling in a very systematic manner, and then we can do it there. So we'll use Erwin and then try to capture all these entities and their relationships. Okay. So I have this Erwin software opened. So Mahbub, I have a question to you. Do you have aim to learn only data modeling? I understand you also wanted to learn dimensional modeling, but do you have any aim to learn Erwin software? Do you intend to learn it, or it is just okay?
No, I need to learn Erwin also.
Okay, yeah, good. So do you have Erwin used in your projects or any other
Yes.
data? Erwin is used. Okay, then it will be useful. So I can clearly tell you how Erwin works too. So so we will be using Erwin, and a conceptual model in Erwin is when we create a model. Erwin supports these three different type of models. One is logical only. One is physical only, which is meant for a database. One is a combined logical and physical. When we select logical, it is not specific to any database, which is agnostic to database. Let's go ahead with a logical physical model where you will have a logical side and a physical side to the model. The database, whenever we select a physical or logical physical, we also need to specify for which database. We will select SQL Server. I'll select SQL Server 2008. That's what I have in my machine. You can select whichever database you want. If it is Oracle, you select Oracle and corresponding version. Okay. So creating a new model. So this is a brand new model. There are no objects created. And we did conceptual modeling for the banking information system and identified few entities. And let's create them on Erwin model now. I'm going to keep both displayed. So we have these two things. Okay, look at the right side pane and to create all the entities here. So in order to create an entity in Erwin, you have to select this entity tool here, select, drop. First, we will start with the account. I will use capital letter for all entities. Then also I will use singular names. We will not use plural names for entity name. I'll explain you why we use singular name later. Account, then I'll create a bank entity. Sorry. Then we have branch. If we want to create multiple entities on the diagram, we can press Control key and click few times. Click once, two, like this. It will create more entities. So just, I'll make it fast. Branch, then we have branch manager. Then we have employee. Then we have customer. To give a name to an entity, we have to just select and start typing. It will be editing the name. Employee, customer, transaction. Then notifications. Then address. Customer address. Okay, these are the entities we have identified. I will quickly add the keys. If you look at the Erwin model, you can find every entity has got two boxes. At the top we have the entity name. Then this box is called key area. All the primary key attributes will go to the first box, and all the non-primary key attributes will go to the second box. So we will add a primary key for all the entities so that we can meaningfully define the relationships between them. So first I will have an account number for each account. So each account is identified using an account number. So I have added that account number attribute. Then bank will have a bank name or bank ID as we wish. We can have a identifying thing. In this situation, if this model is meant for a particular bank, there is no specific need to identify a bank, but it is technically nice to have a key. Then every employee in the organization can be identified using an employee ID. Customer will have a customer ID. Every branch in the bank will have a branch code. Every transaction will have a transaction number. To go to the primary key area, we need to select an entity and press tab. So transaction number. Then notification is not something we may have to identify, but still we can use a key for that. Branch manager also not necessarily will have. It is up to the business to decide. A branch manager should have some kind of identification when one particular person become a branch manager. So I'm just giving a very general term for that attribute. Okay. Address ID. Okay, we have this model and we have created all these entities. Now we have to define the relationships between them. So that is the process where we will have a lot of questions. So since we are doing a data modeling exercise, it is certain that every questions will not be answered by the software requirements. So it is practically impossible for a person to write a software requirement specification which covers all the aspects of the system. So it is, let's say if I am a software architect or maybe a data, I'm a business analyst or anyone who is actually capturing the requirements and then translating to software, someone who is in that process, it is their responsibility to go back to business and ask questions so that all the gaps of understanding will be filled. So let's say if I'm an IT person and then I'm developing a software for a business, so I also have equal responsibility to understand that system. It is also understood that a software requirement specification is going to be not going to be complete. So let's assume that this particular requirement specification will not give you answer for all our questions. So we will, while developing this model, we will have those questions and we have to go back and clarify them. So let's say a few things that may be already there that we will just go and model. So bank offers savings or current accounts. So then let's visit the account. So this account has types. Account can be savings or current. Tomorrow there may be a loan account. Then later there may be some other sort of credit card account. Then different credit card accounts. So there may be various account types which is coming up. So we can create another entity like account type. which describe the characteristics of an account type. Then we will add same thing for account type also, account type ID. Then to categorize each account into one account type, we will create a relationship. You go and pick this non-identifying relationship and draw it from account type to account. So right now, this account type ID attribute appearing in account as a foreign key, which means every account will have one attribute that will help you to identify which account type it is. If you want to know more details about account type and its characteristics, we have to go to the corresponding account type entity. It will deal with that. Okay, so this relationship, if you look at this relationship line, we can look at this relationship line is dotted dashed lines, and I'll explain you the dashed line and solid line difference later when we learn more about relationships. Just focus on the cardinality and optionality. What we see on the child side, this is called cardinality. Here it is 0, 1 or more. And what we see on the parent side, which is called optionality, here it is 0 or 1. So it says that each account may belongs to one account type. So this is saying that it may belongs to. It means you can have an account which doesn't belongs to any type. Then what we have to do, is it supported by the bank? It is something a question we have to check within the banking that business by just consulting a subject matter expert from banking. So whether this bank will support an account which doesn't belongs to any type or not. So if they say, we can have some account which is generic type, which is not yet, we do not know the type. Okay, then this may be a correct relationship. So this is capturing the correct business rules in that case. But if you think that it is not possible to have an account in the system which doesn't belongs to any type, every account should belongs to a type, then this particular business rule, what is captured here, is not correct. So what we have to do is we have to make sure that every account belongs to one type. So go to the relationship editor by double click on that relationship line, then it brings this up, and then this change this to null allowed to nulls not allowed. So right now you can find this is 1. That means each account must belongs to one type. Okay, then if we read account type to account, each account type may have 0, 1 or more accounts. So under a particular category of account, or type of account, there may be many accounts. So that way this relationship line, this cardinality marked is correct. Hi Mahbub, are you with me?
Yeah, I'm good. So one question is like, when on the child side, we call it as a cardinality. If it is on parent side,
we call it optionality, right?
Optionality. Okay.
Yeah.
Okay, that's fine.
Okay, so we have this account type and account the relationship, and now let's see the conceptual the requirement. Bank has multiple branches. Then we have something to represent bank. So this is the entity which represents bank. Then we have branch. If each bank, or in this case, it may be a bank, maybe one single instance, but bank has multiple branches. The relationship between bank and branch is going to be, pick this non-identifying and draw from bank to branch. And then you can see bank will have multiple branches. So this is the cardinality, which is for each instance of a bank, how many instances of branch you can have. That is the cardinality. We have it marked here. And then you can find whenever I draw that relationship from bank to branch, it automatically created bank name as a FK in the branch. So whether you really want this relationship, whether each branch should carry the bank name, it is up to us to decide. Not necessarily we may need this relationship too. So if If I delete that, it will go away. If you want to keep all the bank related information, we can keep here. If a branch exists in this system, it may be implicit that it belongs to that particular bank we are modeling. Then you imagine a situation where you are developing a software for a cloud-based banking information system. So you have a database and you have a software that will work for many banks. So if that is the case, this is important. We need to know everything within the context of a bank. So we may draw this relationship line, and a branch may remember which bank it belongs to. So it depends on a particular system's requirement. I'm just going to keep this relationship to have the connections between bank and branch. At least it can have many branches. Okay, so then branch code, bank name, and then we will look at the next requirement. Each branch has branch manager. So each branch, where is the branch manager and branch? Yeah. So each branch will have a branch manager. Then how we have to define that relationship? How we have to define that association between branch and branch manager? Can you suggest something, Mabu?
Yeah, so each branch will have at least one branch manager.
Yeah.
So
that branch manager must be an employee. So this entity is also there.
Branch manager must be employee. So yeah, employee is a parent, right? Employee to branch manager.
Okay, so okay, there are multiple ways to model that particular aspect of branch manager. So one option, what you have suggested is draw a relationship from employee to branch manager.
Mm-hmm. Yeah.
Okay, so I will draw that. Let's see what will be the result. So a branch manager, right now it says that each employee may be a branch manager. Okay, each branch manager, this relationship is going to be, if we name that relationship, how it will look like. This is actually a role played by employee, right? This is a role or a designation.
Exactly, that is a role.
So this each employee may play the role of branch manager multiple times, 0, 1, or many times. Multiple instances of branch manager for each employee may happen. Then each branch manager instance should be one employee, or okay, if we make this mandatory, it should be one employee. So that way branch manager will become
correct
an employee always. Yeah.
So an employee can be a branch manager 0, 1, or many. So one employee might be managing multiple branches. Is that how we need to read?
That it can be, yeah, it can be like that. Each employee may be branch manager for multiple branches. Branch we have not connected yet. We have to connect. How do you visualize connecting branch? Because right now, you know branch manager. We do not know branch manager for which branch till now, based on this model.
Correct. So branch manager to branch.
Branch manager to branch. Okay. So a branch will keep current branch manager then, right? Because if we consider the aspect of one branch having different manager over a period of time, then branch cannot keep branch manager ID, because branch manager ID will change over a period of time. For 1.5 year, one manager, and then for next 6 months there may be another manager. So branch will, if branch is going to remember the latest branch manager, then we can have an attribute here, branch manager to branch. Otherwise, I will suggest we branch to branch manager relationship. So here we are modeling it like this. Employee to branch manager is fine. Branch to branch manager is also fine. Now branch manager is a role played by an employee for a particular branch for a particular duration. So if I go and complete this instance of branch manager, there will be a start date, there will be an end date, and if you want to have a current status, it is good, whether it is active or not. But that is an information derived from start date and end date. So here, if you look at this, employee in itself is not worrying about the role, branch manager role. Branch in itself is also not worrying about it. So when a particular employee become branch manager for a branch, we will have one instance of this branch manager with a number which will identify that. So who is that employee who has become branch manager? What is the branch code, start date and end date?
Correct.
This will capture that, yeah. So this is one way of modeling it. This will help us to maintain different branch manager for different time periods.
So the cardinality we need to check, right? Because branch manager should be having at least one branch, right? It cannot be zero, right?
Correct. Yeah. So we need to make sure that this branch manager, so this branch code FK, this is not optional. So this branch code came through this relationship, this branch code. This employee ID came through this relationship. So this one we made mandatory, and we will make this also mandatory. Okay.
But it can be many, right? Branch manager can be belong to one branch, or it may belong to multiple branches.
Okay. So that is, one employee may be a branch manager for many branches. That is the correct way of saying it, right? One employee of the bank may be currently managing multiple branches.
Correct. Yeah.
So that way you have to, this relationship will take care of that. Each employee may be playing branch manager in multiple branches.
Okay, but if I need to read branch manager to branch, how I need to write? So branch manager always belongs to one branch.
Yeah, branch manager will be always for a particular branch played by a particular employee. Branch manager role. It will have a start date and end date. So let's say I am a branch manager for two branches. One is a place called A, another one is a place called B, or a branch named A, branch named B.
So employee ID will remain same and branch code will change, right?
No, there will be two instances of branch manager here when one person play role in two places, because it will have different start date and end date as well, right?
Correct, but employee ID will be same, na?
Employee ID will be same, and employee ID will be same. There will be two instances of branch manager here, one for one branch, another one for another branch. Employee ID will repeat.
Okay. So branch code will change and branch manager number will change.
Correct, yes. So this branch manager number is just a key. We have not identified any useful purpose till now.
Mm-hmm.
If you try to find a natural key from there, it may be something like combination of employee ID and branch code and start date. That will become a composite. So we can have either not have a primary key, or we can have a artificial key there. Okay, does that make sense, Mahbub?
Yeah.
If there could have been a, let's say if you really do not think about few aspects. One is one employee becoming branch manager at different branches, and also another aspect, which is one branch may have many branch managers over a period of time. If you do not want to model all those aspects in this system, you say that you just need current branch manager. This particular database is meant for an application which you do not really worry about historical data or anything. Okay. Then what we could do was just instead of creating this branch manager table, just keeping an employee ID here as a branch manager is good enough. One attribute in branch would do that, right? if you do not worry about any historical data. You worry about only current branch manager.
Can you explain one more time, please? Sorry.
Yeah. Let's say we say that each branch has a branch manager, and then this particular database need to keep only the current branch manager information, not any previous branch managers. Then what we can do is we don't necessarily need this additional entity, and I'll just delete it. So we have this design. What I need is one relationship line directly from employee to branch, which will
the branch manager will be a
this employee is going to be the branch manager. So I'll just rename it. Let's say branch manager employee ID or something. Otherwise branch manager ID. So this is actually, this branch manager ID is effectively another employee who is playing the role of a branch manager in each branch. This is also a valid design when you do not worry about each branch having different managers over a period of time.
Right.
Okay. I'm pressing Control Z to go back to the situation. Yeah, this is the one I prefer. Okay. Now let's look at next. Each employee of the bank has a supervisor. So we have this employee entity. Each employee must be having a supervisor. That supervisor is going to be another employee. So in that case, one way to model that is by creating a self-referencing relationship. So let's say we will create another attribute in employee, which is supervisor ID. And it is going to be referring the same entity, maybe another instance of the same entity, which is again another employee, and supervisor ID is going to be another employee ID. Right? Does that make sense to you, Mabu?
Yeah, got it. Subject and object, right?
Yeah, correct. Subject supervisor ID is going to be again another employee ID, which is actually supervisor for a particular employee. Let's say I am in my organization, my employee ID is 68, and then my supervisor is another employee, and then his employee ID is 50. So I will be keeping 50 with me to identify who is my supervisor. So that way supervisor ID will stay with employee.
So recursive relationship.
Recursive relationship. So I'll delete this attribute and draw that recursive relationship. So it cannot create that attribute because same attribute name already there. So what we have to do is we have to go to this relationship editor and role name that attribute created by the relationship. So go to the relationship editor, click on role name and say supervisor ID. Click close. So now we will have a supervisor ID foreign key referring to the same entity. So this is how we can create the recursive relationship or self-referencing relationship. Yeah. So that is considered. Then at the same time, there may be a question. Okay, I have a supervisor, but my supervisor might change over a period of time, right? I will move to another project. Then my supervisor is changed. Then if that is the in the case of a banking, let's talk. I was just talking about my situation. So in the case of a banking, one employee is there. That employee supervisor might change over a period of time. So if you want to capture that, we may have to create a separate table like the way we did for branch manager. So since supervisor is a particular role of a person, then for a combination of employee and supervisor, we may create a specific date range and say this is the supervisor for this particular start date and end date. So we may have to capture that information.
Can't we capture in the same employee table?
If supervisor may change over a period of time, we cannot capture. And if you want to model it, same employee table, if you try to do that, it is something, I think you have asked that question. How about temporal data? Something which may change over a period of time. So supervisor is such type of information which is going to change over a period of time.
Because employee ID is the only key here, right? That's why you cannot repeat, huh?
Yes. Employee ID is the key here, but let's say I am an employee, I will have one occurrence, right? I have an employee ID and then corresponding information is there. So if I have multiple managers, I cannot remember all them within one. Just think about table and rows. In one row, you cannot keep all them, right?
We cannot even create a second row with the same employee ID, right? That's what you're saying?
Yeah, if we do that by removing the primary key constraints, if we do that, then employee, yeah, that's not correct. Because, yeah, if you ask if we can do that, if it is primary key, we cannot do that, right? If we consider employee ID as the primary key to identify one employee, then we cannot do that.
Correct. But let us say if we made a composite key, right?
Yeah.
Can we do that? No, we cannot do that.
Yeah, by making an employee ID and then supervisor ID, putting together.
Create date or like maybe start date.
Okay, but that will be a very bad design. We can do that. I agree with you. Yeah.
That time we can keep a history in that table itself, right?
But let me ask you. I will tell you the problem. If I am an employee, this employee table may have some another 50 to 100 attributes which will describe me, right? My further details will be there. So we may have to replicate all them with the next instance or next row, right?
Right.
Then it will violate the data consistency, data integrity rules. So that way, it will become redundant.
Correct.
Okay. So for each employee, one instance is for one instance of employee should represent an employee. That is the best design. So in case of a table, it may be one row represents one employee in this table. Okay.
So now, how to solve this problem now then?
Okay, so in that case, what we have to do is we will not be able to model it like this. Supervisor is a role played by an employee for another employee for a particular time period. So what we need to do is supervisor has to become another entity and supervisor key if you need. Then supervisor is a role played by an employee, one relationship. So for this employee, let's say this particular attribute will tell you the supervisor ID. So I will just role name this to supervisor ID. Then I will create one more relationship, which is for which employee. So I will create that like this. So this is employee ID is fine. So two attributes are there here for supervisor. One is who is the supervisor, then supervisor for whom, that is the second attribute. Then start date and end date. Then there may be some more additional information. In my organization, we had functional reporting and then another type of reporting, operational reporting and functional reporting. So the supervisor can be different type also. So it may further expand with more information. A type of supervision. So here, okay. So this is how we can model the supervisor. If you really worry about, if the system really care about a particular person having multiple supervisors over a period of time, you need to model it with, as a separate entity. Does that make sense to you, Mabu?
But why do we have two relationships here?
One is who is the supervisor, another one is to whom he is a supervisor. One relationship is defining an association between these two, which says who is the supervisor. Another relationship which tells you to whom he is the supervisor. So a combination of two employee IDs. One we named it as supervisor, the role is supervisor. Another employee to whom he is supervisor. Then start date and end date.
So if I read this one, how I need to read like?
Yeah, if you, yeah, supervisor is a role type of entity. So each employee may have many supervisor. So let's take one relationship. This is each employee may have many supervisors. That is, we know that over a period of time, not currently. If it is currently, that is also fine. Two different type of supervisor you may have. So it says that each employee may have many 0, 1 or more supervisors. That is this.
And supervisor can have 0 or 1 employee.
Yeah, from here, a supervisor not can have. Here a supervisor will be, can be, okay, a supervisor can be an employee, but a supervisor must be an employee. So we have to make this optionality to mandatory. So here I will make nulls not allowed. Okay, I'll just place it properly so that it will be more clear. I'll keep employee at the top and then supervisor here so that it will give you a parent child. Two relationships are there, right? Yeah. So here, this relationship we were trying to read, each supervisor will be a supervisor must be an employee. So this is, we made it must. Each employee may have 0, 1 or more supervisors. Whether 0 allowed or not is something we have to ask. Likely a 0 may be allowed. Then this is the relationship which we created for the employee ID to whom a particular person is supervisor. So is that a supervisor is for an employee, or just you can have a supervisor for something else? No. So this also has to be mandatory. So we'll make nulls not allowed. So a supervisor is for employee. Then an employee may play supervisor role for 0, 1 or more times. So when we read it from top to bottom. Okay. Okay. Is it clear? I don't know whether I messed it up while explaining or not. So we have to consider these two. I'm just trying it away. Two relationships. One is when an employee play the role of a supervisor, and another one is when an employee has a supervisor. So let's consider. Yeah, one is this is employee playing the role of a supervisor. Then you can read based on that. Each supervisor role is must be played by an employee. That is the first one. Then here it is that each employee may play the supervisor role 0, 1 or more times. So this relationship can be read like that. So we can parent to play the role of supervisor. This is the supervisor. Okay, this is not the supervisor one. This is the supervisor one. This relationship, we have role name supervisor ID, right? I will name this relationship to parent to child play supervisor role. or supervisor is already there, play the role.
So what is this? We are writing comment here.
I will just show you. I will just display it. Yeah. So now you can see that text here, right? Now you can read it. Employee play the role of supervisor. That way. Then this is for employee has supervisor sort of thing. So we may go to this relationship line and then parent to child. You may mention it here. What is that relationship meant for? Employee playing the role of supervisor and an employee has supervisor. So this way we can read it. So is it clear why we have two relationship and two foreign keys in the supervisor entity?
Because we are having an employee is playing two roles, right? One, he can be an employee, and the other one is he can be a supervisor.
Yeah, it will be different people. Okay. Let's say if I am having my employee ID is 68 and my supervisor employee ID is 50, then this will be a combination of 50 and 68. Employee ID will be 68, meant for me, and then supervisor ID will be 50. That is employee ID of my manager. So those two different employee IDs coming together, and it is not going to be same employee ID. Employee ID and supervisor is going to be different numbers in the same row. Different people coming together for playing a particular role, which is supervisor role.
But if it is a CEO, he is a supervisor himself, right?
Yes. So then what you said is correct. Then so both of them will have same number, employee ID and supervisor ID, right? Except CEO, for everyone else, we will have another supervisor. So that way supervisor ID and employee ID will be different numbers.
Yeah. So
otherwise, if we have self-supervising, okay, maybe same number. It is up to the requirement to decide. Yeah.
So whenever we see a role is playing, and a person is playing different roles, then we need to have two relationships. That's what we need to conclude here.
When a person is playing a different role, not necessarily you will have two relationship. Here, supervisor is actually an association between two employees, two instances of an employee. Not two instances of an employee, two instances of employees. So supervision is an association between A and B both are employees. That's why there are two relationships. Let's say someone playing a role which is an association between an employee and something else, like branch and branch manager. There also employee was playing the role of branch manager in a branch. Then there will be a relationship from branch to branch manager, and then another relationship from employee to branch manager. Employee playing the role of branch manager in a branch. Now, employee playing the supervisor role for another employee. Then two relationship.
Okay.
Okay. Now let's see. Do you have any time issues, Mahbub? Is it okay if we take another 20 minutes?
Yeah, that's fine.
Okay. So next, let's go and see what was the requirement. A customer can open multiple accounts. Okay, finally supervisor we fixed with this one, that we will have the supervisor role modeled as a separate entity. And now we will go to each customer can have multiple accounts. That is what it says. A customer can open multiple accounts. Then it is talking about a relationship between customer and account. Sorry. So what is that relationship, customer and account? Each customer can open multiple accounts. Maboom.
Yes.
So we'll create a non-identified relationship from customer to account, so that there will be a one-to-many relationship from customer to account. So for each customer, there will be multiple accounts. Each account must be owned by a customer. So we will make this relationship mandatory. So here it became one, exact one. So each account must be by a customer, and then customer ID, then account type ID is already there, then that's it. Okay, then let's go and see. A customer can deposit or withdraw cash from account. So we identified there is something called transaction. We have to collect data. We can, if we try to collect information, every transaction should be identified by a transaction number. Transaction is an event, so there will be a date and time. Maybe one attribute or two attribute based on requirement. I will just transaction date and time. Then since we are modeling deposit and withdraw in same entity, then we need to make sure that we know the type, whether it is deposit or withdraw. So transaction type, then there will be an amount. Minimum this many attributes will be there in transaction entity. Transaction date and time, when it happened, because this is an event. Then what type of transaction it is, and then what is the value of the transaction, which is amount. Then we have transaction. A transaction is always performed in the context of an account. So we need to associate, make sure that if a transaction happened, in which account it happened. So we need to make sure that account ID available in transaction. So I'm creating that relationship. A transaction is not meaningful unless we know in which account it happened. So this account number is a must. So let's make this relationship mandatory. So a transaction happened in the context of an account number. This relationship is done. Do you have any comments, Mahbub? Are you with me?
So, but for which customer it happened, we need to traverse through account, huh? Right?
Yes. Yes. Because an account is opened by a customer. So if you know the account, you know who is the customer. If you create another relationship from customer to transaction, then it will become a redundant information. But if you really want it in the database or not is something you can decide later. From a performance point of view, you want it in your database. That is something, a database design question you need to address later, not a data modeling question.
Mm-hmm.
It has to be modeled like this. Yeah. Okay. Now customer can deposit. Customer not allowed to withdraw more than 50,000 in a single transaction. How we can model this particular business rule? Customer is not allowed. Yeah.
Constraint, right?
Yes. It has to be a constraint on this particular attribute amount. So when the transaction type is withdraw, let's say there is a type indicator for transaction type. When it is withdraw, the amount should not exceed a particular amount. Amount cannot exceed a particular value. So it has to be created as a rule or a constraint. So the way to create it in Erwin is creating a validation rule. Go to the properties, and then I'll name it withdraw limit. Then you can add the database expression here. Let's like amount should be less than 50,000. So then we have to attach these to this table. Since there are, sorry, we have to attach to this entity. I will show you how to attach that on the physical side. Not necessarily it will have on the, there is a way to connect, attach it on the logical side. I will show that implementation when we do physical data modeling. Okay, so here in logical side, we can, if we want, we can attach it with the attribute, not with the entity. Then let's see, is there anything else? An account is always opened in a specific branch. Is that already modeled? An account is, if you given an account number, you should be able to tell that this particular account number is account is opened in a branch. So according to this model, can we derive that information? We cannot, right?
We need to join between account and branch.
So we have to, when a customer comes to a bank, you can consider that customer is a customer of the bank, but each customer can open many accounts. Those accounts will be associated with various branches. So what we need is a relationship between branch to account such that account will remember the branch code. So there is a branch code migrated based on this relationship. So now given an account number, you should be able to say in which branch that account belongs to.
Okay.
Okay. A customer can subscribe transaction notification in email, phone, or address. Okay. Transaction notification has to be sent for when a transaction happen. A notification can be sent to customer, and then a notification should know for which transaction, and then if you know the transaction, you know who is the account, who is the customer, and everything. For this transaction number, we will be sending a notification status. You can have different status for different type of notification. Let's ignore all those complications of that. Email notifications, SMS notifications, or any other sort of notification, different status can be maintained. So we will have notification status, and then the data what we need for sending notification is customer address. So we have this customer address, and then we should know a particular address belongs to which customer. So I will draw a relationship from customer to customer address, so that when we may have multiple address for single customer, that is fine. And then every customer can have many address. So we'll have customer address as a separate entity, and we'll have an address type. Business address or home address, like that. Okay, then we will populate customer address with more attributes, city, street, and everything. That let's ignore it now. Customer may have a primary contact number. I'm just going to add that here. Some customer related more information. One is customer name. Imagine there is a first name, middle name, last name. Let's not model all those things. I'll just draw customer name, and then primary contact number, then PAN number, or anything else. So I just added few attributes. For employee, I will just populate employee name. We will ignore any other information. Then branch code, branch will have a location and more attributes. And then account number, account type, customer, branch code. Every account will have a opened date. Then current status, whether it is closed or Then there will be more attributes which describes if it is closed. So I'll just add open date and current status. Okay, any other attributes you want me to add, Mahbub? Model ready. And if I want to properly lay it out, there is a layout tool in Erwin. So if I click on this, it will use the layout algorithms. This is a circular layout algorithm we used. So you will find them clustering entities into groups. This is something account and related entities, right? This is an account entity and these are the related entities to account. We'll find another cluster of entities, bank, branch, employee, supervisor, and branch manager, another cluster. So we can use different layout algorithms too. This is a hierarchy or tree. This is hierarchical layout. So when we click on that, it will place it hierarchically. You can find bank is going to the top. The most independent entity is going to the top, right? Then under bank, we have branch. Then it found different meaningful levels and placed them. So we can use different type of layout algorithms and quickly get them properly placed on the diagram. Sometimes we might come up with a very clumsy diagram and then we can get it quickly done like this. Okay, we have this. Let's switch over to physical side now. When I switch over to physical side, we have the same model. And then from a data modeling point of view, if you look at any data modeling tools, the terminology is like this: a logical side, or even if it is a conceptual model, some tools will support conceptual model, and logical models are separate things. So logical side and conceptual side, these are called entities. And then when you go to physical side, this is called a relational database design. So we call them tables. Even on this model explorer on the left side, you will find them marked as tables. So these are all the tables we have. If you switch over to logical side, you will find them called entities. Okay. So whenever we have these tables and all the relationships, now you may have noticed that we have created all the attributes which are actually columns on the physical side. For columns, we didn't specify any data type. So what it will do is currently it will assume a default data type for all of them. I think default data type is here. It is mentioned as char 18. So if you change these to something else, number or something, it will have that data type. Let me display data types on the diagram. I will go to the diagram properties, table, display column data type. So now you can see, I will lay out it again. Now you can see the model which is displaying data types as well. You can find char 18 because that is the default data type. We have not specified. We have to go and specify correct data type for all the columns.
Okay.
And yeah. Finally, right now, let's say this design, I'm good enough to go with this design. I will change the data type later. And if I'm good to go with this, we can go to actions, forward engineer, schema. Then I can generate the schema. So if I click on preview, it will give me the corresponding DDL. So it will create all the tables, corresponding primary keys, and then it will define all the foreign key relationships as well. So it will produce the database design. If we connect to a database, click on generate, it will connect to a database and it will generate the schema there. So one thing here we had a rule. Since this is an SQL Server database, when I enforce some constraints on the column, I might create a check constraint. So there is a validation rule, withdraw limit. I can normally, what is the way to write a check constraint? I think when we create a check constraint, it will do something like this: check then amount. If amount has to be less than 50,000 for withdraw, and then there is a transaction type. So it will look like this, and transaction type. This is another column. So if transaction type equal to let's say if it is deposit, you don't worry about the amount. So we'll do like this amount. This logic, this expression is up to us. It is depends on amount is less than 50,000. So this is a programming logic we have to think about the syntax of writing a expression, etc. So I will write it something like this, very simple way of saying amount should be less than 500, or otherwise transaction type should be deposit. So only two types I'm imagining, deposit or withdraw. If it is withdraw, it should be a number less than 50,000. Either amount should be less than 50,000 or transaction type should be deposit. Okay, if I write something like this, check constraint like this, it should take care of that rule. But if it is a complex rule, it is up to us to mention that particular rule here with the correct database syntax. And once we have that expression mentioned here, then we have to go to the corresponding table. Here it is transaction table. Go to transaction table properties, and then where is the validation? Yeah, go to the validation, and then create a validation rule. And this validation rule, okay, it was created at a column level. That's why it didn't disappear. So create a validation rule like this, and then this is the one created. So just we'll mention this rule here. I'll just delete this. Okay, so I created a validation rule, and we have that validation rule explaining what it should check, and then we attach that validation rule with the transaction table validation. Here withdraw limit. Here it will when a particular validation rule is attached, we can specify a constraint name. This will go to database transaction withdraw limit, a meaningful name we can specify here. And with check is an SQL server thing. If I set true while generating, it will do a with check. All the existing rows will be checking for consistency with this rule. Okay, so that way right now everything is done. All the relationships, attributes, and everything is done. Go to action, forward engineer, schema. Here there will be some Erwin generated triggers I want to turn off. Then I will, what I will do, I will open SQL server. Now I will do forward engineering these and create the schema in the database, and then we will stop the class, Mabu. Hope you.
Sure.
Okay, I'm just opening the SQL server. I will name it ICICI Bank, one database. Click OK. Okay, I created a database. Now this schema I am going to generate. This is the forward engineer schema generation option. We'll click on preview and see the detail, that is what is all the data types is going to be char 18. How to change the data type we will learn later. This is the schema. Click on generate. Then we will specify this is selected SQL Server 2008. Then I will just mention that local host, and then database is ICICI Bank, and then click connect. Okay, so it generated everything, but there was one problem here. It is actually a syntactical problem on check constraint. When I gave the check constraint, I gave check amount is actually Erwin will add this check part, so I shouldn't have wrote this check in the actual expression. I should have just wrote the expression, then it will automatically formulate into a check constraint and send it. Okay. So we can continue. That is everything else. 33 queries succeeded, 1 query failed. So for failed query, we need to make sure that that particular constraint, what is failed, and that particular constraint properly created in the database. So we may have to redo by updating the syntax of that check constraint if you want that constraint to go to database. So I'll go to that withdraw limit validation rule and make sure that I write it properly. So I have to just write the expression, no need to have check and bracket. This much is good enough. Okay, that is a purely a syntactical thing. And then once we have that everything done, we will have this ICICI Bank database. We have all the tables and foreign keys and everything defined in the database. And we should be able to continue from here. Okay, so what I wanted to demonstrate to you was in the beginning what we had was only a set of requirements. Even these requirements are incomplete. It will not tell you everything what is needed. They are just pointers which will help you to get a conceptual modeling starting point, and from there you have to go and discover what is the actual system looking for, and then we will be able to evaluate a different way of modeling a particular requirement, and then the consequences of modeling it in different ways, and then come up with the best design which is suitable to that particular business. And then finally we will have a database design which you know how it will work in advance. So right now we spend only 1 hour 30 minutes or less than that. We could design this database. So normally we will get days or weeks to design a database so that we can go to the business and come back and then make sure that our design is